it. So the next session before the coffee break will be given by Professor Gjorgji. I will briefly introduce him. So Professor Gjorgji is a professor at the Faculty of Computer Science and Engineering, University in Skopje. His active research interests are designing advanced approaches for automated time series modeling and forecasting, stream processing, and AI operations using an extensive set of state-of-the-art algorithms. Building on 17 years of research, development, and management experience, he now leads a highly skilled team of professionals dedicated to delivering state-of-the-art machine learning solutions to the world. Gjorgji, now the floor is yours. Thank you.
Yeah, thank you. Can you hear me? Can you see my screen?
Yes, we can see.
Okay, great. Thank you very much. Let me just minimize the faces. So thank you for this opportunity to talk to this event. It's a great pleasure to share my experience with so much people in this audience. So you have presented me, of course, but I would like also to add here that today I will talk with some topic that I'm very familiar with, and I will be willing to answer your question after the presentation. So what I'm going to present you today and what I'm going to share today with you is how to develop and how to manage machine learning pipelines. Because the first thing that we are experiencing is basically that we are focusing on only building such a machine learning products, but at the end we are not ending up with only one model, and we need to separate infrastructure where we can build and deploy those models and operate those models in production. So what I'm going to share some insights I will give you about the state of the machine learning right now, what is happening within the industry depending on their development from the different areas. I'm going to talk about the machine learning life cycle that probably all of you that have some kind of experience of machine learning have a previous knowledge on that. And we are going to introduce the machine learning operation paradigm, which deals with the problem of management of machine learning models. Then we will state the difference between the DevOps and the MLOps paradigms, where the DevOps paradigms is some part of the continuous integration and continuous delivery of code, while the MLOps paradigm will add on top of that model management, model monitoring, and everything that comes up with additional challenges with the machine learning field. Then I will continue to describe the maturity levels within the machine learning operations, and then I will share with you some essential best practices for machine learning operation paradigm that you will need to be aware of. So one research that have been made by Gartner in 2022 says that basically in the last decade, what we have been posed at most was developing of the models, building machine learning models. So we have been dealing with what type of features we are going to gather, how we are going to transform those features, how we are going to make the normalization, the standardization of the data that we have, and how we are going to build the model, optimize the model, pick the right model, of course, on the other side, make the tuning of that model, and test and validate that particular model. And we have been not being focused on the operationalization of that model. Because of that, we have not dealt with so much models basically in our infrastructure. We have built only 1, 2, 3 different models depending on the task that we have faced. But actually our focus was how we can build the models and what is the best approach to build a model that will answer the stakeholders' needs. Today, 53% of the POCs make it into production, which means that almost or more than half of the machine learning models that we are building and we are trying to solve some kind of specific problem we are trying to put into production to see how they will behave in production and how much benefit they will bring to us. But what are the costs outside of that? It says that the time that is needed to put some model into production, especially if you have multiple models that you want to play with, we need on average of 9 months basically to put those models into production. And it says that by the end of 2024, 75% of organization will shift from piloting to operationalizing AI. What does it mean? That practically everybody will want to take the opportunity to use some kind of a machine learning models that will be used in production and to take the advantage and also the benefit of data-driven modeling and decision making, of course. So how everything started? So in my experience, because I have started with this topic somewhere in 2012, 2013, everything started with a small team that actually tried to build some models for multivariate time series forecast, where we try to build some specific models, multiple different models for forecasting, classification, also regression. But what was the steps when we have started about this thing? So the first thing that we would like to address here is the scoping part. So we need to define the machine learning problem. We need to define the data-driven problem that we want to solve on one end. Then we need to somehow gather the data and store the data that we think that those data are interesting or at least could be beneficial for solving that particular problem that we have identified and we have defined, of course. And usually what we have done basically in the data gathering part or the phase of the problem is putting that data within one database storage, which was time series database storage. And that data was stored there. After some period of time, it was updated, changed specific periods of time within that data storage. But at the end, we have ended up with a huge mess of data that was not tracked when they was updated, when the first and how the data were updated within the database that we have. And of course, when we have tried, at least our team tried to build that model, build that specific models that we have been interested in, they have been downloaded all the data to their computers, to the local machine and local store. And basically from that point on, they have been working on that particular time series data that they have derived within that process. And then the modeling have been started. So once you start the modeling process, you're trying to identify the specific features that you're going to use. You're making some kind of a data cleaning. You're making some kind of a anomaly detection within the data that you have. And of course, at the end, you are ending up with small subset or even not small, but definitely some kind of a subset of the data that you have downloaded or even the data that you have stored within some server position where all the other participants in the project have access to. But they do not have a clue how did you make that anomaly detection. They do not have a clue how you have made the transformation, the normalization, the standardization of the data, and many more transformations that you have involved in the process. And once you try to build a model, you're taking your data set and trying to make some kind of a training to your model and then try to validate that particular model. Once you validate that particular model, you're finding out that those default parameters are not something that you would like to have and try to make some kind of a optimization, hyperparameter optimization. And the first thing that you're trying to do is to just get some experience of how the model behaves. You're starting with the manual process of fine-tuning or the optimization, hyperparameter optimization of the particular model. And after several iterations, you're figuring out that you have obtained bunch of different results that you have not tracked anyhow, because the first iteration you have noted that in your notebook, of course, but after several iterations, you just try to remember what was the results that you have achieved, how the model behaved for a specific set of parameters that you have made. And at the end, you have a model that you don't know how did you converge to that model, how did you make the decisions on which that model was built. So you don't know which of the data you have used. You can check, of course, the last model that you have built, but what about all the models that you have produced basically in the previous iteration of that modeling process? So you don't know how did you achieve those results. You're trying to identify which are the most important features. You are trying to identify which of the metrics that you have used are most related to the features and the transformations that you have seen in that process. And all of that is a huge mess. And after some periods of time, you are figuring out that you are not tracking anything about that process of generating and building a model. And you're finally realizing that you would need somehow to try to track all of those experiments that you are making. And this is only the first part of the story. After some period of time, you're trying to somehow note all of those decisions that you have made, also all of those parameters that you have seen within the process of building the machine learning models. But at the end, you can see that actually, even if you note all of those things, it's hardly manageable, that process, within the big team if you have, or even a small team of 2-3 people that are working on that particular problem. And somebody comes to you and say, okay, I get a new best results, and those best results are within this span. Okay, that's very nice. The other member of the team also come and I managed to have also much better results that we have seen in the previous days. But once you observe and analyze how those results have been achieved, you can figure out that actually that they have used completely different set for validation, completely different set for testing, completely different set for training the model. So it's not just the parameters about the model that you have, but also the whole process you need to track. And you need to be familiar with the validation, how you're going to provide the validation, how you're going to provide the hyperparameter optimization. You're going to, you have to manage the process of testing the model and training the model as well on the other side. So in one point of time, you realize that you will need some kind of a tool. And that tool basically will enable you to track all of those experiments within your process, which is quite crucial in this moment, because otherwise you're not able just to reproduce anything of that, how you have produced a separate model and achieve specific results to that model. And then the other curse is coming up. So once you develop the model and you are very satisfied with the model behavior on the test data that you have selected, you need to deploy that model. And you don't have an operational pipeline that will enable you to deploy that model in production, but somehow with several scripts, you're trying to deploy that model. And you're figuring out that if you are using different type of libraries for the modeling part that you have used, you will need to separate serialization techniques just to be able to serve that model in some on some endpoint, just to be able to use that in production. And if we are using some completely different tasks, like for example stream analytics, you will not be able to do that within a decoupled endpoint server that will able to serve your model. But instead of that, you'll need to make some kind of in-memory deployment of the model of the specific process that you're using. And then you're facing with the problem, how much memory I have within a process that I can deploy that model, how big is that model, how is the time complexity of that model and the inference time of that model. So a lot of things that you need to basically figure out while you're making these steps to the deployment. And of course, in the end, after you deploy your model in production, it does not end up here. You need to somehow monitor your model because you're working on real world data. You're not having a test set. You don't have a laboratory environment where you can exclude different types of data and you can work only on the data that you want to work. But in the real world use case, you'll be familiar with a lot of different data drifts that you can see across the time, and you should be able to monitor the behavior or your model on your end. And in one point of time, when some kind of a thresholds and the benefits are not that big from that model, you'll need to figure out how you can change that model. And of course, you don't want directly to change that model or just put out of production that model, but you would like to have some kind of a backup plans, and several models should be in production, so you can also somehow track all of those models and monitor their behavior in order to be able to exchange them once it is important to be changed some specific model. So all of these are some kind of challenges that we have seen in the machine learning area, and that is part of the machine learning process. I'm not even touched the specific topics of developing the machine learning pipelines and developing and the transformation that we need to include in that process. But we will need to know how to address these challenges, especially because right now maybe we have a good solution to optimize and make some kind of a convention regarding the testing of the model, how we are going to track the experiments within the model. But at the end, we need to find out a way how we are going to deploy those models and operationalize a huge number of models in practice. And also the monitoring of the models is not like monitoring a deploying software, whether it is active or not, but you need to monitor many different things in order to figure out whether it gives a benefit to the specific user. Also, the debugging of the machine learning model is an extremely complicated art, because actually once you figure out that the machine learning model does not behave as it behaves within the test environment, you need to somehow identify where are the problems that you have experienced and to solve those problems. And like I said, models rely on real-world data for predicting, and real-world data changes, so should the model as well. And we need to keep track of new data changes and make sure that the model learns accordingly to those changes. And I just want to put some additional complexity here. For example, right now with all the privacy issue and GDPR, for example, you have a model and you know that you have trained the model using some user-specific data, and of course you have obtained some consent of the users to use their data. But just imagine that even now, if those users are not willing to share their data to train your model with those data, they can always pull off the data that they gave a consent to you to train that model. So you will need to deal somehow with the problem of excluding those data from the specific user and retrain the model and build the same pipeline and build the same model without the data from the specific user. And you don't know in that moment if that user does not give a consent anymore to the already used data, how you're going to use the model that you would like to build, and of course the performance that you are going to achieve with that model, because the user-specific data could be crucial for that particular model and the generalization that they have been involved in the previous step, of course. But what does it mean for the industry? On the high level, what kind of challenges we have? We have that many companies struggle to integrate machine learning into their existing infrastructure, so they do not have a proper infrastructure. Of course, we have specific tools that can help us, but please believe me that for different machine learning problems, every particular tool is not a solution. Like I said, for example, for time series, we have built a specific specific platform, MLOps platform, which is specific to time series data, because you can optimize the whole pipeline end to end for specific type of data, of course, in order to tackle some specific scenario on the other end. And there is no one magic tool that can solve all of your problems. So you need to estimate the problems that you have, you need to estimate the challenges that you have, and you need to try to, by using specific tools and developing and customizing those tools, to implement some specific solution that will solve your problems. What is the key point that you will need to focus? Basically, to focus on managing the entire life cycle, not just building the model. Nobody will be interested about how your model works best in the laboratory environment. Everybody wants to see that your models could operate in on a production level and see the benefits out of those results that you have achieved with the laboratory environment. So what are the two phases? I already explained the two phases. The first phase is the research and the experiment. What is our focus? Our focus is the data. Our focus is the type of the model that we are going to use. What kind of a problem we are going to solve. How to define the problem, how to scope the problem, how to identify the best feature sets, feature engineering techniques, transformation techniques, and identify the whole pipeline that will be involved for solving some specific problem. And these are specifically scientific projects. And what we are doing in the EuroCC project is just trying to somehow identify those problems, define those problems, and help the companies to build the proof of concept regarding these specific problems that they will face off. But in the second phase, there is another challenge that is not more related to the data scientists, but is related to the data engineers, basically, and the software engineer that should put these to operational state. But it does not mean that the data scientists finish with their job, basically, in the first phase. They need to closely collaborate with the software engineers just to be able to identify what are the specific scenarios and how those models will be used in order to be able to put those models in production. And in this second phase, we want to answer the following specific question. How do we implement this model at scale? How do we pipe the data into the model in a timely fashion? For example, just imagine you need to somehow deliver that specific data. Recently, we have worked in some specific project that actually we have to deal with around 500,000 different data points in a second that should be somehow analyzed, and based on specific features, we need to provide some anomaly detection out of those data points that we are going to gather from different sensor data. But the first question that I have stated is how you're going to deliver that data, because 500,000 points to deliver in one point of time to some infrastructure, especially if you sensor that data from some kind of a field, is not an easy job. And you need to somehow deliver that data in order to be able to judge or to estimate something to the data that you have collected, of course. And what are the typical scenarios here? That after the POC, after we have managed to investigate whether some kind of a data-driven solution could be beneficial for our potential client, can bring the machine learning model in production, or what kind of migration of existing models into the ML platform that we are using or we plan to use is possible or not, because not all of the ML platforms that we can see, especially from the platforms that are built from the big companies, can handle all the different types of models that we can build, of course, and some kind of customization we need to provide. So if we combine both phases, we can see that the machine learning code that we have started with is just a small piece of the whole mosaic that we need to provide at the end to build some specific solution. So the data scientists somehow build this infrastructure and this code here, but the software engineers, data engineers have a much bigger job to fulfill in order everything to be put in production. But in specific point of time, this environment, surrounding environment of the ML code is one thing that we need to provide in one point of time, which means that if we develop the right infrastructure, or we select the right infrastructure, we can see that basically after that we can operationalize much easier and have a much lower time to market for our models that we have created in the laboratory or the laboratory environment. So what is the MLOps? What is machine learning operation? It's nothing more than just a set of practices. And all of those practices that I'm going to talk, I already mentioned the challenges, and those challenges we need to convert right now in practices. Basically, we need to efficiently manage the creation, deployment, monitoring, and maintenance of the machine learning models. So machine learning operation bridges the gap between data science and IT operation, automating and streamlining the ML, the machine learning lifecycle. So what does it mean? That means that all of the challenges that I have stated previously, they need to be converted and automated and streamlined within the infrastructure that you are going to use, or you are even planning to use, of course, in the end. What is the starting point for machine learning operation? We have some experience regarding the DevOps development and operation, where we would like to streamline somehow the development of a new code within some specific application. So what we have done, we have starting with thinking how we can just put in production our code, especially we have a collaboration from multiple members within the team. So we have some kind of a centralized repository or different type of repository, distributed repositories like Git, and everything will go in one particular repository. After that, we need to somehow make the testing there. We need to somehow provide the integration of the different components, and then we need to somehow deliver that code into production. And that is some part of that that is called continuous integration and continuous delivery, whether the deployment of the production of the artifacts within this pipeline is manually processed or completely automated process, depending on whether we are involving continuous delivery or whether we are involving continuous deployment of our code. But of course, this is just the beginning, because our code, after the integration phase and continuous integration, continuous testing of this code, once it is deployed in the production, we can see that it behaves according to the test that we have provided to that code. But in data science and machine learning is completely different. We are not only trying to integrate and deliver and deploy the code, but we are also trying to build and deploy the data pipelines and the machine learning artifacts on those infrastructure. And of course, our work does not finish here. This is just a beginning where we are starting to deploy our code and data pipelines and the machine learning pipeline, and we are starting another process that is more related to the monitoring and evaluating and estimating the benefits that that model and that machine learning pipeline can bring to the end user. So we have, like I said, continuous integration and continuous delivery of the software. And this process basically ensures that the ML models are integrated and production ready. But it does not mean that we have, like I said, finished our work at the end. So how they are different? Machine learning operation experimental in nature. Basically, most of the activity of data science teams relates to experimentation. And teams constantly change features to their models to achieve better performance while also managing an evolving code base, of course. We have a hybrid teams. We have the data science team. We have the developers or machine learning engineers, also the data scientists and researchers who analyze the data and develop different models and algorithms, keep track on everything, and try to put some other models in production that they need to be tested. They need to be verified that they behave at least the similar as the model is in production, and a lot of things surrounding only continuous delivery and continuous deployment of the models and the data pipelines. So we need to have at least provide some kind of a continuous testing. To the regular, this is in addition to the regular testing stage of the behavior of that particular model, such as unit test, functional test, and integration test. And also this MLOps pipeline must also continually test the model itself, because the data could be changed. You are not be satisfied only if you test the model on one specific data set, and that data set is just could be biased or even have not good distribution of the data, just to be cover all the use cases that you need to cover within your problem, of course. So we have here automating retraining. Okay, we have developed the model, we have trying to test the model, we are monitoring the model, but what after some specific period of time? And this is very important, for example, for the time series data problems. So after some period of time, you're aggregating a lot of new data, and that new data you would like to see integrated within the model that you have, basically because you would like to follow that distribution of the new data that is coming. So you need to decide how that new model will be developed or even retrained, whether you're going to take all the data that you have used previously for the previous model, or you're going to have some kind of a Windows technique that will include the new data, but also will include some of the historical data that the previous model have been training. All of those decisions should be made, but those decisions cannot be made just from the operation point of view. That could be made basically based on the machine learning problem that you're trying to solve, but also together with the data scientists, because they highly are relevant, their knowledge is highly relevant for the topic or the problem that you're trying to solve. And basically with a combination of both forces, we can manage to establish a whole automatic process within the retraining of the models. Then you need to see the performance. You are going to see the performance degradation, because after some period of time, you will see complete data shift with your data distribution, and you will experience some performance degradation of the model, and you need to decide in which point of time you're going to retraining some specific model or build a completely new model that will be able to tackle the data drifts that the previous model have experienced. And of course, we need to make some kind of a data monitoring, of course, on the other side, because we should not believe on the third-party services, especially if they're providing us the data in our automated pipelines. So it means that we need to somehow monitor the data that will come, how those data are different from the data that we have previously received, whether they change the measuring unit for that particular data, or whether there is some specific anomalies. And you will need to have a specific machine learning pipeline that will deal only with the data monitoring. Maybe you're going to introduce another specific machine learning models that will be able to detect specific anomalies or specifically tag specific data that you would like to use within the retraining process. So you will have another machine learning pipeline for just data monitoring and data decision, whether they are going to be included in the process of retraining of the specific model or not. So a lot of complications could be added here, but in order to deal with all of those complications, you need to somehow think of some automatic regular pipeline that will enable you to deal with all of those challenges here. What are the maturity levels within the machine learning operations? The first one is the low automation or high error risk, which means that all of the things that we are going to provide to production will be completely manual. Even the development of the model is completely manual, and that is the first stage of maturity level. So it means that we are sitting in front of our computer, we are just opening Jupyter Notebook, and we are just making some kind of a model, building some specific model. We are not tracking anything regarding the data. Basically, we are just downloading the data to our specific computer or server, depending on the amount of data that you have, make some transformations, make some data analysis, and based on the data analysis, you're choosing some specific model, and then manually deploy that model in production, basically. But this is first stage, and you don't want to be part of this stage because it's very hard and also error-prone, this maturity level. You would like to be at least here on the first level of automation. So you want to have some kind of an automation, especially orchestrated experimentation part, and manual intervention is needed afterwards for the deploying. So at least you would like to have some kind of a convention or even protocol or even strict rules how somebody needs to develop the model, what kind of parameters he needs to track for that particular development in order to be able to reproduce those models and be able to measure the differences and to evaluate the different models in the same way, just to be able to see what is the the best model that you have right now, or to even estimate to which use cases that particular models could benefit from. And in the end, we have the full continuous integration and continuous delivery, and also monitoring of the machine learning pipeline, which enabling you rapid iteration. So it means that almost everything is automated, and you don't have to, you have established a whole process for how some specific model could become a part of the production setup, how that model could be switched in a dynamic environment, and there will be no needed from manual intervention for that particular process. So visualized this process, what does it mean? We have, like I said, some kind of a database store where we have all the data that we have. Maybe we can create a separate local store of all of the data that we have. Then starting with the data preparation here, then model training, model evaluation, then model analysis, going back, and this feedback loop. Once we are done with the model development, we need to basically somehow put the model in some kind of a repository or storage that model. Then the model should be deployed in a completely separate, in a completely manual process. And like I said, everything with this is okay if you're developing 1, 2, 3 models for different tasks, but just imagine that this is not the case right now, because we are trying to tackle many different problems with many different data that could dramatically change across the time and update it across the time, and we will like somehow to put that into some kind of a frame, of course. And the second stage is already a good start, I would say, where we have an orchestrated experiment. And that orchestrated experiment enable us at the end to track how everything was developed. I know that model that was produced. I know exactly how that model is produced. Basically, how that model is trained, what kind of feature transformation technique have been used, what kind of feature engineering technique have been used and applied, in which point of time, how they have contributed to the results of that model. What are the evaluations measures that have been used in that particular process? So everything of that is somehow trackable, and that is part of the experimentation process. And you can see in the following presentation that for this particular topic, we have a brilliant tool like machine learning flow or ML flow that is called, which completely enable you to automate or at least track this process within the machine learning pipeline production setting up. Then the model going to some kind of a repository where that model afterwards somebody needs to take care of and make that deployment. And of course, the second level of maturity, which is the complete automation, we have been until now somewhere here. So we need the model development have been completed. Then we need to continuously integrate that model. Then we need to continuously deliver that model. But at the end, we need to continuously training, service that particular model, and then monitoring that particular model. And this here is always a loop, some kind of a loop, and in which time that model should be based on the result that they have that model achieved, maybe it will be completely discharged basically from the machine learning pipeline. So in a better sketch how everything functioning on this part, we have two separated phases: experimentation phase, development and testing, and staging and pre-production and production stages we have here. So in the first level of maturity of the MLOps pipeline, this is completely automated here, but this is already manually conducted. But in this automation pipeline, this also is automatically conducted basically. So what does it mean? That means that the experiments are basically made by the data scientists. All of those experiments are tracked, and once they believe that they have the good models, they can put those models into some kind of a pipeline deployment, and that pipeline is deployed to some kind of a staging environment where that model is monitored and no real life data is used to monitor the behavior of that model. Once we are satisfied with that pipeline or multiple different pipelines, we are going to pre-production, where a limited number of real life data are streamed, are routed to that particular pipelines. And if we are satisfied with that particular pipelines that have been developed, we put those one into production. And of course, once they're in production, we need to somehow always monitor their behavior. And in one point of time, how we are developing new models, basically, we are always comparing the different pipelines. And in some point of time, we are going to switch, even automatically, we are going to switch the pipelines that we have developed. Why? Because we have established some kind of a measurement or evaluation technique that will tell us that, okay, this model right now that is built after, I don't know, some period of time, after the first model generation, it can be better. So you can just switch those models and use that specific model in production. But in order to do that, you need to also be very familiar with the problem that you are trying to solve, because applying those techniques is not part of the operation. That is part of the AI governance that you will need to have, especially from the data science team. So what is the essential practices that we need to be familiar with? The first one is automate model deployment. That will enable us consistency, faster time to market, and seamless updates, I would say. We need to establish that process because in that way, we can continuously produce models and be able to deploy those models to some specific environment like staging or pre-production or production environment, but at least we will be able to easily deploy and not make any mistake regarding that particular process. While we are establishing this kind of a architecture or platform for automating the whole process, we need to think of very simple models in order to build the right infrastructure, general enough infrastructure, or selection of a specific platform or tools that we are going to use in order to be able to somehow address different types of problems in the future. So we don't need to focus on a specific problem that we have currently, because like I said, after some period of time, you are going to figure out that basically building a machine learning infrastructure for all different types of problem is not possible. So you will need to combine different tools. You will need to make some kind of customization in order to optimize that infrastructure, so you will be able to tackle different kind of problems afterwards. But thinking of this as a problem that you'll need to start with is always a good choice to have simple models, small models, just to be able to test the environment, see how it will behave on a production level. Recently, what we have experienced with is some because right now we are discussing about machine learning operations, but now there is a new movement, which is a new paradigm, new practices regarding the large language models, for example. And now we have, on top of machine learning operations, we have add multiple different steps in order to be familiar with and fulfill the large language model operations part. So we have been testing some specific tools for tracking all the conversation with the large language models, and we have seen then that some specific tools are not even able to tackle with such an amount of data that they should tackle with. For example, we are saying that the model should be first and simple at the beginning, but at least at the end we need to test with the production data that we have and to see how that infrastructure will behave. Like I said, for streaming scenario, for example, you have a completely different problem, and there it's not possible your model to put under some third-party server. For example, put on a separate endpoint and a separate server instance, because you would like to deal with high velocity of data, and basically to deal with that velocity of data, you don't have another choice. But regarding putting that model basically in memory for specific in the specific process where you're receiving that particular data that you have. But the simple model will enable you to select the right infrastructure, to select the right practices, the right concept that you would like to test with, and you'll have a easier debugging. You'll be able to provide some kind of a scalability and integration. In order to build a robust infrastructure, you need to consider the following components. You need to consider the data ingestion, like I said, because the data ingestion is very problematic part of these pipelines, where many different data, even with different modalities, could be somehow stored, should be retrieved in some point of time, and they should be used accordingly to build some specific models. And I mentioned, for example, a lot of time series problems that we have worked with. But just imagine, or the problems that we have faced in, for example, for the time series problem, time series modeling problem. So you have a lot of different sensors that are coming out with different frequencies, with different latencies. So you need to figure out how all of those data should be ingested and packed together in order to be able to exploit those data together. Because to localize first and then to localize according to the time frame, you always need to have the data that you are going to use in one point of time to have on one place, but also you would like to have the data aligned according to the time component, because you're not you should not basically accept to store the data in a different time intervals, because otherwise you're not be able to use the data afterwards for the modeling part, or the modeling part will be very difficult in the end. Then you need to consider the model training. The model training is very specific because it requires a huge amount of resources, and you will need to somehow scale this up and provision, and also to plan this in order to be able to build this infrastructure. Then you will need to consider the model deployment, how you're going to deploy that particular model, and then monitoring and logging, of course, and the security and compliance for that particular model. You should always think of enabling shadow deployment, which means that you need to have multiple models in the background for the same particular task, and to monitor all of those models in order to be able to change and switch those models if some model experience performance drops. And of course, you need to provide always performance comparison with the different models. You need to have a mechanism how to monitor the results of those models, and you will need to figure out in which point of time you are going to switch the models. And in the similar fashion, like in the data analysis scenario where you're analyzing the anomalies there and what you should use of the data just to fit the models. It's the same here. Maybe you're going to have a specific machine learning model that will decide whether one particular model will be switched with another from the production environment, just to be able to understand how complex this could be at the end. When we're working with supervised problems, supervised learning problems, we are always have the problem of data labeling and how that environment is controlled. And in my opinion, and also the opinion for other data scientists, is that this is very crucial for supervised learning, because you need to be familiar with how those data have been, how that data is labeled, and what is the quality of the data that is labeled, and also of the labels of the data. It means that it's always better to have a controlled environment and to track the whole process of data labeling. Always use multiple annotators just to be able to use multiple opinions, and of course monitor and audit the labeling process. You cannot trust other data services or data sources, so you need to always provide some kind of the data validation, detect anomalies, and monitor the data drift. And especially this is very important for the production environment, because in the production environment you are going to see a lot of invalid data, because there is no data platform that is completely reliable and perfect. So you need to take care of the data quality, especially for retraining the models, but also for measuring the performance of your model that is currently in production. Because if you have some kind of a garbage in, even in the test, in the production testing of the model, you're going to have garbage out. Always try to build some kind of a reusable scripts for data engineering, especially for data cleaning and data merging, because you can always use and reuse those scripts for making a better quality of data and not involving additional errors with every step of this pipeline. Especially this is happening with newcomers, where they are not aware of the current streamlines that are basically established within the company, and you will need to really take care of that within your company. Also, enable parallel training experiments. So you need to provision some kind of infrastructure that could be distributed, but also parallel. So you can make multiple models in parallel. So you can invoke more models and faster iterations of the different experiments that you need to conduct. Evaluate training using simple, understandable metrics in order to see what are the benefits of the models. You need to always align with the business objective and try to use that kind of a metric just to be able to explain how that model behaves and what are the limitations of those models that you are generating. Automate hyperparameter optimization. Of course, you don't want to end up with a manual process of hyperparameter optimization. You need to make some kind of you need to use some kind of techniques like grid search, random search, Bayesian optimization, and etc. But you will need to know that even if you're using this kind of hyperparameter optimization, you can always experience different complexities of the models. And also you can experience for some hyperparameters convergence problems. So it means that you need to be very careful with this hyperparameter optimization automatization, because otherwise you can end up with a lot of problems. You need to continuously monitor the behavior of the deploying of the deployed models, and you need to have multiple performance metrics. You need to always check the data quality, like I said before, how the resources have been used, and also many alerts and notifications that will tell you what is happening within your automatization platform. Also, here we have fairness and privacy of the data. You need to keep track of the data that you are using. Like I said, now with the GDPR, the user can always request from you to basically stop using the user data for training your models. So you need to somehow keep track of the user data. Even they are anonymized, you need to provide immediately another model that will not include the user data if the user requests that one for you. Improve communication and alignment between teams, establish clear objectives, maintain documentation, and hold regular meetings. Use version control for all of those techniques. Please note that this is just part of the MLOps problems. Right now, what we can see and the tools that we are going to discuss afterwards about the machine learning operations that are not capable to face off our current large language models. For example, for the large language models, right now we have one specific model that could be used for different type of tasks. What does it mean? That I can use for classification, I can use for summarization of some particular text, I can use for entity recognition or name entity extraction of some particular text. So one particular model with for multiple different scenarios. So how you're going to monitor in that case that model? What is the model in that case? Is the model that you're using like the large language model, even if you are fine-tuned with low rank adaptation or something else? What is the model in that case? Maybe the model in that case is just the prompt that you are writing, and based on the prompt, you are experience different behavior of the large language model that is used in the background, or the fine-tuning of the specific model that you have done. So a lot of topics have been attached to these machine learning operations regarding the large language model, which is not part of this presentation, but still you need to be familiar with all the complexities that we are facing of. And just a small set of different tools that could be used for machine learning operations. I said that there is a machine learning operations platform that basically offer all of those specific steps automated, already incorporated in their implementations, like Amazon SageMaker, Azure implementation of the machine learning operations platform, Databricks platform that they have built, etc., etc. But also there are specific tools that could be used for the different for the automation of the different parts of the machine learning life cycle and the flow, of course, like the DVC, the thing that we are going to introduce, and that is for the data versioning control, similar to the Git versioning control, but this is specific for data. You have machine learning flow or ML flow tool that deals with the tracking, experimentation tracking, which is very helpful, in my opinion, when you are trying to establish kind of a process. Kubeflow, you have TensorFlow extended, LakeFS, another tool for data tracking and changes, and etc. So a lot of tools and a lot of platforms are offered right now. So you need to pick and find the specific one that you need according to the problem that you would like to solve. But please know that you need to first establish general concept, how you would like to tackle this problem. And then once you are familiar with the problem that you would like to solve, or the different types of problem that you would like to solve, you will need to customize the current solutions that you are going to select. And after some period of time, you're going to establish specific processes for the specific types of problem that you're trying to solve in the end. So what are the conclusions? Without MLOps right now, we cannot do anything. MLOps is critical for maintaining and scaling machine learning models. Automation in the machine learning pipeline unlocks faster innovation, of course, but it's also crucial to basically eliminate the errors within our pipeline of producing new models and solving specific types of problems. And companies that embrace machine learning cooperation will gain a competitive advantage. And those that will not use those practices and paradigms will have a complete disadvantage. Okay, thank you very much.
Thank you.
I would be very pleased to answer your question.
Thank you, Gjorgji, for this informative talk. Yeah, we do have some questions in the Q&A. So the first question is that for the continuous development part, if we continuously test the model on the same data set, can we truly say that its performance is improving? Or do we need to fine-tune and update the data set to keep up with the development process?
So when you're dealing with this kind of problem, you have a data set. And based on that data set, you are trying to build or identify specific model and specific transformation features that will be enable you to solve that particular problem, just to estimate how that model behave and how that model could be good in the production environment. And what I would like to know, at least when I have some specific data set, is what could be the best machine learning pipeline that can solve that particular problem based on that data set. And of course, once you're developing the model, you're identifying those parameters, specific models, ensembles of models, etc. But the most important thing is to evaluate the model in the same fashion. How somebody is trained the model based on the same data set is not that important. How you're evaluating the model in order to get the most informative results of that model. And of course, that is one dimension. If you have additional model that you can also add to the machine learning pipeline that you have already established, you can add that and see how that model behave out of that additional data set that you have used and additional data. But at least for me, the first dimension is to see how I can achieve or how I can obtain the best model out of one specific data set in order to know how to proceed and which are the most beneficial or the most concrete models and machine learning pipelines that should be used for solving that specific kind of a problem.
So another question, can you give a comparison result on ML maturity levels and DL maturity levels?
There is no strict comparison. It depends what you would like to automate, basically. If you are developing only one model, then you don't need any kind of automation here. Basically, what you will need is only a built model, test that model, and of course, put that model into production, which could be quite easy with current tools that you can use. But on the other side, if you have a team of multiple teams that work on specific problem, the first thing that you are going to experience is comparing the model. So no one will be built and evaluate the model in the same fashion. If you don't make a strict protocol and convention how that model should be evaluated, you will not know anything about that one. So you need to somehow think of it how you can establish a process. And MLOps is just a process. And you are trying to identify the process, what is the right process, and trying to build that process and automate that process. It depends from what you need, but at least it's always to have process. Sometimes the process is the overhead of the development. But at least in some point of time, if you have so much models that you need to develop, so much data that you need to track, monitor of that data, it's always better to have kind of a process and automate that process in order to reduce the errors and also to reduce at least the risks to get errors in that specific automation.
And final question.
Yeah.
I have a time series project related to market sales. I don't know how to handle extreme outliers because they are related to promotions. Should I keep those outliers or do I need to find a way to figure it out?
Uh, I said that we have worked on uh, many different projects with time series, and I'm very familiar with this kind of a problem. And what I would like to put here is that you will need to have a separate machine learning pipeline just to deal with the anomalies. So you need to somehow label those anomalies, detect which of those anomalies will be included and which of those models, which of those anomalies will not be included in the machine learning model that you're going to develop. And that should be part of the production level environment. It means that some of the data you are going to use in the specific pipeline, and some of the data you will need to decide automatically that you are not going to use. For example, right now, this sales weekend, the last Friday, Black Friday, that's completely outliering if you compare to any other date basically in the year. So you cannot use the same model that you have used for all the year. You need to provide a separate model. You need to detect once those outliers will came into your model, and just to be able to switch or retrain somehow the model with all the other data that are not following the same distribution or the expected distribution. Because in my opinion, Black Friday is just an anomaly of the whole year. But the trends within the Black Friday, for example, is completely different model, is completely different behavior that needs to be modeled with specific type of models and machine learning pipelines.
Thank you. And there are lots of thank you messages. Thank you again for the presentation and also for the contribution.
Thank you very much for the involvement. Yeah.
I think we will now have a 10 minutes coffee break. Okay, then we will continue. Thanks.